0 at the beginning, the middle, and the end. So I go ahead and do that. Then I call it the quarters. At the quarters, it's up its amplitude and then it's down its amplitude. So in this case, my amplitude is going to be 1 because this is just a normal trig function. We're going to look at examples of what we're going to do in the assignment here in just a minute. In fact, I was getting ready to write one over here. But before we start examples of your assignment, I want to get all 6 trig functions on that sheet of paper, so you have an idea what it's looking like. You guys have questions so far? Next one, cosine curve. 0, 90, 180, 270, 360. Everybody, we're good to go? And if I go too fast, just let me know. Cosine curve starts at its amplitude, ends at its amplitude. Halfway, it's down its amplitude. At the quarters, it's 0. So again, cosine curve starts at its amplitude, ends at its amplitude. Halfway, it's down its amplitude, and at the quarters, it's 0. So then we connect. And this is for one cycle or one period of a cosine curve. This is for one cycle or one period of every 6 trig functions we're going to do. And you can flip if you're right large, you may want to put some of the graphs on the back sheet of that white paper. Doesn't matter as long as you get them so you have your sketch to go by.
Ms. Davis, I think we already have this in our notes.
Do you?
Yeah, I think so.
Okay, well, we'll just, I don't know what you had, so I'm going from, I'm an overkill, you might say. Okay, tangent. Can you tell me about tangent then?
It's a
asymptotes.
Asymptote where? That's the key.
0,
Quarters.
90,
Nope.
90 degrees plus 1.
Middle. It's always at the middle. And I like my asymptotes in different colors. Okay? And it starts at 0 and goes to it. And comes from it back to it. Okay, so tangent curve has an asymptote in the middle. I'm going to go to the cotangent right beside it. And the period or cycle of a tangent or cotangent, yeah, it's 180 divided by our coefficient of our angle, which we're going to get to here in just a minute. Yes, sir.
The asymptote on the tangent, is that at 90 degrees?
Yes, it is.
Okay.
It's always going to be at the halfway point. The key thing, it's not always going to be 90. We're going to be changing periods, we're going to be changing amplitudes, we're going to be changing a lot of things to it. And then when we add that phase shift, it's going to change even more. Okay, cotangent. Where is the asymptotes?
0 and 1.
Beginning and end. I don't like to say 0 and 180 because it's going to change. So we're going to say beginning and end. And now what's the cotangent curve look like? Starts high, ends low. Starts high, ends low. Which I think I'm going to be getting ready for a test for you. Review on the Monday following here, so the test would be in that range there. So it'd be the following week. Okay? Now, let's look at cosecant. I'm going to squeeze mine in, but you can make yours as large as you need it. Where are the asymptotes on a cosecant curve?
Beginning and end. Oh, the middle.
And the middle. Beginning, middle, and end. Now think about it. Isn't it the inverse of the sine? Where's the sine 0? Beginning, middle, and end. So where's it gonna be undefined? Beginning, middle, and end, because it's the inverse of that. So we're gonna have asymptotes at the beginning, the middle, and the end. Then whatever the coefficient of the trig is, which in this case is a 1, is where the parabola is gonna start and where it's gonna dump the water out. So the first half normally holds the water and the second half lets the water out. But it's gonna start not at 0, but whatever the coefficient of that trig happens to be. If it's a 1, it's gonna be 1. If it's a 5, it's gonna be a 5. Okay, let's do the secant curve. And again, I'm squeezing mine in. Secant curve, what do you know?
Asymptotes at in the 90s.
I say the quarters. The quarters, because it's not always going to be 90 and 270. So where cosine was 0 is where this is going to be undefined, right? So it's going to be at 90 and 270. I say the secant curve is like a window curtain. You know, when your parents open the curtains and they pull them back, you know, with the little hooks on the side? That's what it is, except in the middle you got a parabola down there. So it's going to start at 1 and go to it, come from back it. See, there's the window curtain. Everybody see the window curtains? And then in between, it's going to be a parabola letting the water out. Yeah, you could call it that. Okay, so everybody got your graphs good?
Yeah.
Mason? Question, or are you just writing?
Yeah.
Okay. I'm known to have fast markers, so you sometimes have to slow me down. Then we're ready to start our examples. Now in every problem, I want you to state the amplitude, the period, the graph. So that's what I'm going to show in examples. Increments, I write it down until you got used to it. Most of them, you can do those up here. You don't have to write it down, you can think. So here's going to be example 1. It's that one I started to write. Okay, so what do we know? You got to tell me the amplitude. The amplitude is the absolute value of the coefficient of the trig. So what's the absolute value of 3?
3.
3, good. And I abbreviate a lot, so you can as well. Now, how do we find period? What's it tell us that we have to do to find period?
360 over k.
Okay, and the k is the coefficient of the angle, or that's also called the argument. So it's going to be 360. And notice I put on my little chart, you can either use 360 or 2 pi.
Yeah, you guys.
You can do it in radians, or we can do it in degrees. It's easier for you most of the time to do it in degrees. So if you want to change to degrees, you can. So 360 divided by 8, what is that going to be? 45?
Yeah.
Is everybody agree? 45.
4 is 90.
So now, what are the increments going to be? What's it tell us to do to find the increments? And the increments are these. That's what we go by to get our graph drawn.
So it'd be period divided by 4.
So what's my period?
45.
So what's 45 divided by 4?
No,
11 and a fourth?
yeah.
Okay, does everybody agree there? Okay, now we're ready to graph. Yes, Mason?
Where are we getting are we dividing the 360 by what? What are we?
The coefficient of the angle.
Okay.
Number in front of the angle.
Alright.
Okay. The increments is found by taking the period divided by 4. And it's always 4, if you noticed on my little sheet, it gave you that background. So now, we're ready to graph. So you're starting at, right now, all the problems today, you're going to be starting at 0 degrees. When we have that phase shift, it's not going to be 0 degrees. Okay, so right now we don't have to write this down, but we're gonna start here and we're gonna end here. We're gonna go by increments of 11 and 1/4. So what's 0 plus 11 and 1/4?
11 and 1/4.
What's 11 and 1/4 plus 11 and 1/4?
22 and a half.
What's 22 and a half plus 11 and 1/4?
33 and 3/4.
What's 33 and 3/4 plus 11 and 1/4?
45.
And if you've done things right, what should it be?
Should be
45, right? Should be our period. Okay, now what's true of a sine curve? First, our amplitude's 3, right?
Yeah.
So that means 1, 2, 3, 1, 2, 3. We aren't 1, we're gonna be up 3 and down 3 somewhere. Now, what's true of the sine curve? What did we say? You're 0 at the beginning, middle, and end. Beginning, middle, and end. See, it's not always 90 and 360. Do you see my motive to my madness there? Okay, and then on the quarters, we're at our
Highs and lows.
Yeah.
high and low, which is our amplitude. So we're gonna go big up 3 and down 3. And mine literally are sketches. They're sketches of the figure. Now today you're only going to be doing sines and cosines. I just wanted to have all 6 trig functions so we'll have them, because we're eventually going to do them all. In fact, I've got a couple worksheets prepared for next week, Monday and Tuesday, where we're going to add the phase shift. We're going to do all of them. So it'll be 2 days of making sure you understand what you're doing really well before we move on into the book again. Okay, so amplitude, period, phase shift. We don't do phase shift because we aren't ready for that yet. So what is our amplitude?
is
2. Period. How do I find it?
360
So it'd be 360 divided by 1/2.
Which is
4.5.
multiplied by
So
360 divided by 1/2 means multiply by 2, so 720.
Yeah.
And now what will the increments be? How do I find the increments?
divided by 4.
Divide the period by 4, right? So 720 divided by 4 is what, 180?
Yeah.
And the period is in degrees.
Yes, these are all degrees unless you want to go to rads. And the only time I would go to rads is if they have pi involved in the problem somewhere. Is everybody okay with me there?
How come the amplitude is 2 and not negative 2?
Because you take the absolute value of it.
Okay.
Remember those symbols are on that chart. Now, the negative does affect the graph. So you're going to see here that in just a minute. Okay? Now, where are we starting?
180.
No.
0.
0. So we're starting at 0. We're adding increments of what?
180.
What's 0 plus 180?
180.
Plus 180
316.
plus 180.
450.
Yeah.
540.
There we go.
Transpose your numbers. And last, I hope,
720.
you know you're right if you get to the right ending point. Okay, is everybody good there? Now, what's our amplitude?
amplitude is
2. So 1, 2, 1, 2. Now, let's think about it. What does it look like? Well, kinda. It starts at its amplitude, ends at its amplitude, halfway it's down its amplitude, at the quarters it's at 0, right?
Yeah.
But, did you notice this was negative?
Yeah. So it'd be the opposite.
So opposite, it flips it. So starts negative, ends negative. Halfway it's going to be positive, and at the quarters it's going to be at 0.
Oh.
Okay, good? Example 3. And if you feel good, you don't need to write down any more examples. If you want to write more, write more. If you want to just soak it in, all I'm going to do for a little while is I want to make sure I get to learn your names and try to call on everybody to answer a question for you, okay? So don't shout it out yet. Okay, so I guess it's Delaney D. Davis, last name, must be related, I guess, huh? So amplitude, Delaney, what would it be?
Absolute value of -5, so 5.
Good. Zach, period. How do I find it?
360 divided by K,
So what's my K?
5,
So what's 360 divided by 5?
72.
72. Okay, increments. I think, is it Dalton, is that right? Did I remember it?
Yeah.
Okay, Dalton, what would be my increments?
So it'd be 72 divided by 4,
Good,
18.
good. So, that means, Mason, we're going by increments of 18 starting at 0, right? Because right now we don't have a phase shift. So what's 0 plus 18?
18.
What's 18 plus 18?
32. Or 36.
There we go.
Yeah.
What's 36 plus 18?
54.
Good. What's 54 plus 18?
72.
And our amplitude is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this is a sine curve. So Delaney number 2. What is true about the sine curve?
It's at 0 at the beginning
And
and in the middle.
and the middle. So beginning, middle, and end. What do I do otherwise?
The first quarter it's at 1, the second is at -1.
Okay, only in this case it's not going to be 1, it's going to be,
5.
okay, and,
-5.
right, so we're going to start at a -5 down and then 5 up. Okay, are we good? Mason, good? The ample 4. Becky. Amplitude.
Oh no.
Good. Period. I'm gonna sneak on your name. Taylor. I think I got that half learned. I just gotta get over here. Taylor, what would be your period?
360 degrees divided by 1/3.
So 1080? We good?
Yeah.
Okay. Now, what are those increments gonna be, JC?
1080 divided by 2.
So that's gonna be what?
270.
270 is right. So we're gonna start at 0, and this is Richard, and add 270, so what will I have?
270 at the first, 540 at the next, something, no. 8 times.
Uh-huh.
And then you would end at 1080.
I hope I ended 280, right? Because that's what we want to end at, right?
Yes.
Okay, now, amplitude is 1/2, so I've got 1 and a -1 here. What's the graph of a cosine look like, Delaney?
It is equal to 0 at the quarters.
That is good. So quarter 0. And then what's it do other than that?
It's a positive 1, so at positive 1/2, it'll be right there, yeah.
And then it ends at a half?
Yeah, and in the middle is -1/2.
That's it. Okay, how confident you guys feel? Or you need more examples? Couple more. Again, you don't need to write these down. If you want to, you can. I can keep making these up till I'm blue in the face, so just so you know. Let's see, I'm ready for Zach. Amplitude, period, amplitude first.
6.
Period. I do?
360, no, period is, yeah, 360 divided by 1, so.
Good job, so 360, I was trying to trick you. The coefficient was 1, wasn't it?
She has that drained in our practice.
Good, I'm glad. I didn't think I'd have any problems with you guys, I figured you'd all be trained right. Mason, what about increments?
It would be, 360 divided by 4,
Which is?
90.
Got it. Okay, Delaney number 2. We're going by increments of 90, so what am I gonna have?
90, 180,
0, 90,
180, 27, 360.
got it. And what's a sine curve look like? Well, we have an amplitude of 6, better get that on there. Beginning, middle, and end. And down 6. Okay, Mason, need another one?
No.
You think you got it?
Mhm.
Okay, we're doing 18 through 34 even. Make sure you show me everything. I have bad feet, in fact, I'm supposed to have surgery in May, so it would help me, I wanna see everybody's first 3 problems. As soon as you get them, bring them up and let me look at them, okay?
For the problems when it uses that, is that just like X?
That's it.
Okay.
And we could put an S and a T in there too. In fact, my textbook does, which I don't like. So I always change everything to X's.
So we're going to coefficient.
Yeah, this is the coefficient of the angle, and that's the coefficient of the trig.
Or the argument angle?
Argument is also called an angle.
So argument angle or just argument? Sorry.
It's the same.
Okay.
This is the angle.